Good afternoon, everybody. Hope you're all well and having a good day. I'm Chaitra. I'm a security engineer at Yahoo. The security team at Yahoo is called the Paranoids, so I'm a paranoid. I've been a developer for a long time now. I've spent more than 15 years coding, debugging, testing software in various technologies and domains. And now I'm focusing full-time on security. So today I want to share with you some things that I have learned about IAC SAST. Hope you find it useful. So I just want to get some definitions out of the way so I can start using this short form in my presentation, right? So what is IAC? IAC is nothing but a collection of machine-readable definitions in the form of your code, script, policies, templates, which are used to deploy and provision your infrastructure. And SAST, as you may all be familiar with, is nothing but static application security testing. It's a methodology that analyzes your source code, now your application's code, in our case, for this talk, the infrastructure code, to find any vulnerabilities in them. The main objectives for this talk for me are today to introduce you to IAC SAST, give you some examples of IAC SAST tools out there, and to answer some obvious following on questions of why do we need IAC SAST, and where in our DevOps cycles would these IAC SAST tools fit in? Who are any Star Wars fans here? Oh, not many. Okay. Well, if you would have enjoyed these imageries. Anyway, so the next 3 slides are the TLDR for my presentation. So we are all on our cloud journeys. On-prem, private cloud, public cloud, does not matter. And we are all in a rush to containerize our applications. And we've been smart about it, and we've used infrastructure as code to deploy and provision our infrastructure, which is great. I mean, because that allows us to kind of deliver a fast software quickly. So that's good. And we are delivering our software faster than light, which is great. So what can go wrong? Well, as it turns out, quite a lot can. So if you have not made sure that your infrastructure code does not have any misconfigurations, or if it has not been coded properly, then all these misconfigurations can lead to potential vulnerabilities in your infrastructure when it is deployed. So then what do we do about this? So we do want to use infrastructure as code because we do not want to deploy our infrastructure manually. So we still want to use IAC. Then how can we find these issues early on during the development cycle? Well, as always, Yoda has an answer for this. So Yoda says, install or implement IAC SAST in your workflow. And I think I agree with him. That was basically the nutshell, my presentation in a nutshell. So feel free to walk out and get a break. But for those of you who want to know more, let's carry on. So I'll briefly introduce to you what IAC is before jumping on to introduce what IAC SAST is. And to fully appreciate why we need IAC SAST, we need to first understand, and I need to scare you a bit here. We need to see what are the possible vulnerabilities that can happen in the infrastructure because of misconfigurations in our infrastructure code. And then I'll show you some examples of IAC SAST tools. Then we'll see how we can deploy this into our DevOps cycle. And I'll conclude. So IAC, woohoo, yes, we all need to. IAC is the way to go about it. We do not want to do stuff manually. So we need IAC. That's a smart thing to do. So again, briefly, what is IAC? IAC is a collection of your machine-readable definitions for your infrastructure, which you have coded, which is in the form of configuration files, templates, policies, scripts. Now, again, these are all in the file format, so which means this can be version control. So all the goodness of the version controlling comes with it. And there have to be some tools that understand how to read these files and then go ahead and do what is necessary to deploy and provision your infrastructure. That your likes of CloudFormation, Terraform, Kubernetes are some of the examples. So these tools understand your code that you have written and go and deploy the infrastructure for you, your network, your security, your storage, application infrastructure. Here are some more examples of some IAC tools out there in the market today. This list is not complete or comprehensive by any means. It's just to give you an idea of what an IAC SAST tool is. You might be familiar with this. So IAC has a lot of benefits, and that's why I said it's a smart thing to do. So it helps you automate your workflows. And because it's in the form of a file, which means you can repeat it. You can use the same file or the template to deploy your infrastructure and provision it in different regions, or maybe you can hand it over to your other teams in your organization as a reference template. And because there is no more hand cranking involved, that means it's scalable. And if you've ensured that your template is secure and there are no issues in them, no security misconfigurations in them, then you can be assured that when this code, infrastructure code, is deployed, that your network and your infrastructure is reasonably secure also, right? And as Darth Vader correctly points out here, if you have not made sure that your infrastructure code is secure, then all these benefits that I listed here can so easily turn into pitfalls. I hope you can understand that. So, yes, as I said, to fully appreciate why we need IAC SAST in our workflows, we need to first understand what are the possible vulnerabilities that can happen in the deployed infrastructure because of the misconfigurations in your code, right? So let's see some of the dark side of IAC now. I have listed some potential misconfigurations that could lead to potential vulnerabilities in your infrastructure. So in the first one here, network exposure could happen if you have not been careful about configuring your firewall properly, if you've not made sure that your cloud storage devices, your databases are not available publicly, which normally you don't need to make it publicly available. And for whatever reason, you've left your SSH ports open to the public, right? And yes, unauthorized privilege escalations can happen if you have not stored your secrets, your keys properly, or maybe you're running your containers as root. And yeah, or maybe you've given too much permissions to your resources, which could lead to improper access control. Or maybe you've not enabled logging at all on your, maybe on your S3 bucket, and maybe your logs are not encrypted. So that's one of the OWASP vulnerabilities of insufficient logging and insecure logging. How do these misconfigurations in your infrastructure code happen? They can happen for a lot of reasons. So it could be a simple oversight by an engineer, or maybe the engineer who is coding this infrastructure file, configuration file, is new to IAC. Maybe the developer comes from an application development land, is not familiar with how to code an infrastructure file. Or maybe it's a complex IAC configuration file and it's code after all, so no code is bug-free. And we have fast-moving DevOps cycles these days. There could be gaps in our testing, or maybe we are depending too much on our pen testers and our dynamic testing tools to find issues in our deployed infrastructure, and so not paying enough attention on our testing our infrastructure code. Well, I have some industry reports here to back me up on what I'm saying. So in the first report here, this is from 2021 IAC Research Report from Sneak. And what I want to highlight here is that about 45% of the misconfigurations or vulnerabilities in the infrastructure was found after it was deployed. And according to the survey, it took them more than a week to discover a security issue, if that was discoverable, I would say, and more than a week to fix those issues when found. So as you can understand how stressful it would be for an engineer. First of all, it's very expensive to go about fixing these, and then very stressful for the engineers who are fixing it. Here in the second report, industry report, this is from the security team of Palo Alto Networks. This is a cloud threat report where they do show you all the different types of vulnerabilities that were found in the publicly available infrastructure code templates. But another thing that this is kind of very new, this information, what they're trying to say here is that it's very important to secure your infrastructure code in order to secure your supply chain. So here they're taking example of Terraform, and they're saying that your chances of having misconfigurations in your IAC file increases as the number of your Terraform modules that you're including in your code also increases. And they're clearly pointing out here that these misconfigurations are not happening because of the public cloud provider you're using, nor because of the IAC tool, like in this case Terraform, that you're using. But these are happening because of us, the coders, who are using these modules incorrectly, coding them incorrectly. So if I have not scared you enough, let me make it more relatable to you and make it easier for you to understand how these can happen in your code, right? So let's see some examples of how these misconfigurations can happen in your code. I've taken these examples from the publicly available TerraGoat project. This is from Bridge Crew. TerraGoat project is a very interesting collection of files. They have a collection of vulnerable infrastructure as code files. So it's a great tool to use when you are in the process of selecting an IAC SAST tool for your organization. Say you want to evaluate a tool, you want to benchmark a tool, then I would say go check this out. So yeah, let's go through these examples. In the first case, so as I've highlighted there, so the SSH port 22 was left open to the whole world, and we know it's not a great idea at all. In the second example, the S3 bucket is not encrypted at rest. Here in the third one, there was no logging enabled on the S3 bucket. And here in the fourth example, there was no fine-grained access control for your Elasticsearch. I hope I've scared you enough now, so this would be a nice segue to introduce IAC SAST to you. So let's try and see now how IAC SAST can rescue us, right? Help us find out these misconfigurations in our infrastructure code very early in our development cycle. So what is IAC SAST? IAC SAST is static analysis of your infrastructure as code to find any security misconfigurations in your code. So ideally, it should look like this. So you have your configuration files, your templates, scripts, and policies, and you have your IAC SAST tool. The SAST tool runs a scan on your configuration files, and it reports a bunch of findings. And these findings should be fed back to your developers or production engineers, whoever is working on it. So they fix it, and they fix this in your configuration file, in your templates, rather than fixing them in your infrastructure file. So as you can see, this is truly shift left. This is so close to the developers. You are fixing issues in your code even before the infrastructure is deployed, right? And another point I want to make here is that you might say you have dynamic testing tools, or you have your pen testers testing your infrastructure. So why would I need an IAC SAST tool? But you see, there's more information in your infrastructure code than you would normally have once your infrastructure is deployed. Two examples that come to my mind are improper access control. I doubt any dynamic testing tool would find that. And yeah, maybe good pen testing would find that, but you would need to have very good test cases, bad test cases to find those improper access control issues. And another one is unauthorized privilege access. So again, here, you would need really good, say for example, your containers running as root. I don't know any tool out there that could find this for you, unless you have good pen testing. Now again, how many of us do good pen testing? Yeah. But these things can be found by just simply scanning your infrastructure code. I ran an IAC SAST scan on some of those vulnerable examples that I showed you previously. I'm here taking Checo, Bridge Crew's Checo, as an IAC SAST tool example. Again, to point out, these are just examples. I'm not promoting any tool. This is just so you get an idea of how this can be done. So when I ran the Checo scan on those vulnerable files, in the first case where the SSH port was left open to the world, it clearly shows that what the issue is in the code and where in the file is the issue, and it also provides some kind of guideline as to how can I go about fixing this issue. In the second one, it clearly says, ensure all data stored in the S3 bucket is securely encrypted at rest. Here in the third one, it says, ensure the S3 bucket has access logging enabled. For the fourth one, ensure IAM policies does not allow write access control, access without constraints. So I hope at this point you understand, briefly, get an idea of what IAC is, what are the misconfigurations in the IAC that could lead to potential vulnerabilities in the infrastructure, and how IAC SAST, by running scans on these infrastructure code, you can find these vulnerabilities early on in your development cycle. And now I'll show you some examples of IAC SAST tools out there, which you can use to run your scans on these configuration files. Here are some popular IAC SAST tools in the market today. Again, this is not a complete or a comprehensive list at all. Just some examples, and I'm not promoting any tool. But I thought it was only fair to point out some of the tools that I have used. And it is a very fast-moving market, this one. Any big security company, tool provider that I know is in a rush to also offer an IAC SAST offering. So very hot topic, very fast-moving market. So you go do your own research, benchmarking, and evaluation of the tool to decide what tool would suit best for your organization. And in order to do that, here are some criteria, according to me, which are important when you go about selecting an IAC SAST tool for your organization. First and foremost, it should support the file types that your organization is going to use. Kubernetes, CloudFormation, Terraform, or these days the new kid on the block is Pulumi, I think. So you have to make sure that this tool supports all these file types. And it would be nice if it could support some of the industry security standards like CIS and NIST. And you do not want to run these tools manually. That's not scalable at all. So the tool should have the ability to integrate with your software control management systems like GitLab or GitHub. And yeah, output format may become important if you want to forward your findings from the tool to a dashboard for easy viewing metric. And ability to understand the context and resolve references in your IAC becomes important because you might be including other modules from other Git repositories. So if the tool can also scan that and get a better context of the code, then that would mean low false positives, right? Yeah, I missed a point there. So high signals to noise ratio is good. I've seen that some tools out of the box have better signal to noise ratio, that is low false positives, compared to some others. Some tools perform better in some areas and some others in something else. So again, go to your research and benchmarking to figure out what suits you best. And if you could add your own custom rules, custom checks, and maybe modify the existing checks, that would be handy. Of course, like every other tools, you have the open source version and the paid version. And paid versions have some fancy dashboards available. They have integration with your GitHub, GitHub app, GitLab, GitHub's app applications, and they can report the issues to you, so you can go and fix them or open a ticket. So, and I've been saying static analysis, but these static analysis tools can also these days run a scan on your runtime environment and see what is the difference, what is the drift between your runtime environment and your code. So I think this is handy, so that once you find what the drift is, you can go back and fix it in your infrastructure code. Well, I would recommend never go and fix it in your deployed infrastructure, rather come back and fix it in your code so you come up with a secure template to deploy it again and again. Now that we've seen some examples of IAC SAST tools, let's see how we can deploy it in our DevSecOps cycle. Here is a simple user flow diagram from a user's perspective, a developer's perspective, right? So it would be ideal if the tool is integrated locally in the IDE, or maybe in the local Git, right? So that the developer, as and when the developer is coding, the developer gets an immediate feedback, and they can go and fix this issue then and there, and integrate it with your Git again. Say on your code commit or add, you get an instant report, instant messages to say, okay, here is the issue, and you can go and fix it this way. Or you can incorporate it into your CI/CD pipeline, wherein you say, okay, do an automatic scan on every pull request, and then you can make the findings. You can make it gated or not before you deploy the code. Some tips for efficient integration of IAC SAST tool. This is not just for IAC SAST, but true for any SAST tool, even your application SAST tool. So ability to integrate with your IDE and SCMs like GitHub, GitLab for immediate feedback, and integration into your CI/CD to automate your workflows. You do not want to run these things manually. Believe me, they're not scalable at all. And high signal to noise ratio is very important to keep the developers engaged and motivated to go look at those findings and fix them. Otherwise, I'm telling you, don't even bother with a SAST tool because it's not effective at all. So, how can you go about doing this? So I've seen that most of the IAC SAST tools, true also for the application SAST tools, what you can do is you can pass in your customized configuration files where you can just focus on we're talking about security here, so you can just focus on maybe security issues first. So I came up with such a configuration file for one of the tools I'm using in my organization, and there I just focused on the security issues and masked all the maybe high availability issues, your best coding practices. They are definitely not important in the first run. We just want to find high value and meaningful findings as I said, so that the developer is motivated and engaged and they want to look at the findings and fix them, not just throw an IAC SAST tool at them and which reports like hundreds of findings. Nobody's going to look at them, triage them, and fix them. So in one such example, I found that by just masking out the non-security related issues, I could bring down the number of findings from 143 to 16. And effective false management is important so that when you find the issue and you see it's a false positive, you can immediately go and say, okay, mark this as false positive so that it does not come up again and again in your scanning. And low friction security experience is also very important. Neither the tool nor the security engineer, I believe, should become a bottleneck in your workflow. We should trust our engineers. And as security engineers, all we can do is provide them a good tool, provide them a good set of high-value configuration files, and give them enough guidance and baselines so that when there's a reporting, they can go check out the guideline or the baseline for that and go fix it themselves. So we have to start trusting our engineers and take ourselves out of the workflow. It's very important to find that balance between the security risk and value flow. Here is your typical DevSecOps cycles. I'm not going to go into the details here. What I want to show you here is where in the DevSecOps cycle would your IAC SAST tool fit in. So, it fits in the coding stage, as I said, plug it into your IDE or with your Git for immediate feedback. And in your build cycle, wherein on every pull request, maybe you want to automate your scans. To conclude, I hope you now see why we need IAC SAST and what are the different IAC SAST tools out there, and where in your DevSecOps cycle can you fit these IAC SAST tools into. Just to reiterate, so IAC SAST, unlike your dynamic testing tools and your pen testing, it finds issues very early on in your development cycle, very close to the developers. So that helps develop a secure mindset to the developers. So as and when if they get the feedback saying, okay, you've not configured a user for your container, they're not going to repeat the same mistake again when they're coding. So it helps develop a secure mindset. And once you arrive at the secure template, it kind of becomes like a paved road approach. You can hand these secure templates to other teams, or you can use the same template for deploying in other regions, having peace of mind that this is a secure template, and so I'm not going to find many vulnerabilities in the infrastructure once it's deployed. And the developers need not be security experts to run these scans, find the issues, and fix them, as long as we've given them enough guidance and baselines to tell them how to go and fix it. Again, I'm not saying your IAC SAST tools are replacement for your dynamic testing tools or your pen testing, but what I'm saying is complement your dynamic testing tools and your pen testing with IAC SAST to find issues very early on during the development cycle so you can fix the issue in the code. And this is truly shift left. And we know shift left means less effort, less money, and less stress. So we can never ensure that our infrastructure is fully secure, 100% safe. But what we can do is make sure that we have taken care of all the known vulnerabilities in our infrastructure and make it as hard and difficult as possible for hackers to infiltrate our systems. So why wait? Use the force and go deploy IAC SAST in your workflow. Thank you. Any questions? Yeah.
So which tools are open source?
Yeah, in fact, yeah, everybody from here, I think, as far as I know, they have an open source version and they have an enterprise paid version. So there's a trade-off, right? So in the open source version, you'll have to make sure that you're using the latest, greatest, and you have to plug it into some kind of your GitHub, GitLab, or whatever. And once you have the findings, how do you report it? How do you send it to a dashboard, maybe? So there's extra load work for you if you're using open source. And then if you're using paid version, somewhat you get all that, because it's a paid version. So all of these tools have an open source version and a paid version. Any other question? Hi.
Another question. How good are those tools when you have like more advanced system, when you have like layers and all that?
Yeah, that's what I said. So it depends on how well do they understand the context, and if you can say you can also pass in not just scan this directory or these files, but also look at these other directories which could have other definitions, right, to understand the context better. So depending on if the tools allows for it, and I've seen most tools do allow for that, but at the end of the day, they're still SAST tools, right? They do their best. But as I said, if you pass in high value checks to your tools, then you can make sure the false positives are low and you only find meaningful results. Yeah, thank you. Hi. Yeah, for SCAs, well, it's not really related to SAST, what I'm talking about. You're talking about software composition analysis and vulnerabilities in the libraries that you've included or third-party code. For that, you have a lot of tools out there. My colleague here can tell you more about it. But yeah, there are a lot of, again, tools out there which kind of scan your code software and the binaries to see what kind of vulnerabilities are there. I can talk to you later, or my colleague here can talk to you more on SCA if you're interested. Any other questions? Okay, I think we're good. Thank you. By the way, we are hiring if anybody's interested. Anybody wants to become a paranoid, contact me later. Thank you.